In this universe, there are countless things that go completely against human intuition. A famous astrophysicist once said, "If stars didn't actually exist, humanity could easily prove that they cannot exist." And that's the truth of our universe. The things that science once labeled impossible often show up in front of us, forcing humans to realize that impossible was just the boundary of our own understanding. And the cosmic monsters we're talking about today, they are the extreme laboratories of the universe. Take the sun, something so familiar, so ordinary, yet it is the very first creature in the monster catalog. The warm light that touches Earth every day comes from an enormous nuclear furnace, one powerful enough to vaporize entire planets into plasma, yet held together by gravity so strong that the explosion never fully happens. By earthbound intuition, this kind of thing should explode or collapse within minutes. But stars burn steadily for billions upon billions of years. And the secret is simple. Gravity pulls inward, radiation pushes outward. Inside a star, these two forces are locked in a cosmic tug-of-war. If they stay balanced, the star lives. When that balance breaks, the star transforms into something far more extreme. The first monster, the neutron star. When a massive star dies, gravity crushes it so violently that atoms collapse, electrons and protons merge, and what's left is almost pure neutron matter. In 1967, Jocelyn Bell at Cambridge noticed a signal in her data, a perfect pulse, every 33 seconds, so precise it rivaled an atomic clock. For a moment, scientists genuinely thought it might be a Morse code from an alien civilization, but it turned out to be a rapidly spinning neutron star. Its density? Imagine compressing Mount Everest into the size of a sugar cube, only about 10 to 20 kilometers across, yet heavier than our Sunday. When this thing was confirmed, the scientific world froze, because most physicists believed an object like this, simply could not times exist. But the universe proved otherwise. And even then, the neutron star was not the final form. When even neutron matter collapses under gravity, the most extreme object in the universe is born, the black hole. Its gravity is so intense that even light cannot escape. Time slows near it, stretches, bends, and then freezes. Everything that falls in is pulled toward a point of infinite density, and humans cannot describe what happens inside because all physical laws break down. Einstein's general relativity predicted black holes, yet even he doubted that they could truly exist until Cygnus X1 was confirmed and impossible became reality again. Black holes not only validate relativity's wildest predictions, they expose the deepest conflict in physics today. Quantum mechanics and general relativity completely disagree about what happens at a black hole's heart. But the universe didn't stop there. It built an upgraded version of the black hole, the quasar. In 1963, astronomers spotted a bright point of light. It was 2.5 billion light years away, yet 100 times brighter than the entire Milky Way. All that power came from a supermassive black hole, devouring matter at insane speeds. Its accretion disk blazed at hundreds of millions of degrees. Photons were blasted outward like cosmic bullets, a region smaller than our solar system, outshining a whole galaxy. That was the quasar. But even quasars aren't the final boss. The true endgame monster is the gamma ray burst, a flash that lasts only seconds, sometimes minutes, yet releases as much energy as our sun will radiate over its entire lifetime. If a gamma ray burst ever pointed directly at Earth, it wouldn't need to hit us. Just its radiation could wipe out every living thing. In 1967, when US satellites detected the first gamma ray burst, the military panicked, thinking it was a superweapon from the Soviet Union. Only later did scientists realize these explosions happen billions of light years away. Each burst carries 2 centuries worth of the Milky Way's total radiation. They arise when giant stars collapse or when 2 neutron stars merge. For a moment, the environment becomes as extreme as the universe itself, 1,000th of a second after the Big Bang. Now the opening quote suddenly feels very real. If stars didn't truly exist, physicists could prove they were impossible. Human intuition comes from Earth, but the universe never follows Earth's logic. In environments of 100 million degrees, densities beyond atomic nuclei, and space-time folded like paper, the rules of physics to reveal their other face. And these counterintuitive monsters have pushed modern physics forward. Neutron stars drive quantum theory. Black holes challenge relativity and quantum gravity. Quasars reveal how black holes grow. Gamma ray bursts explain stellar death and the origin of heavy elements. And the monsters we know today may only be the appetizers. With the James Webb Space Telescope looking deeper than ever and new sky surveys scanning the universe, we may soon discover more objects that should not exist. Cosmic creatures, ready to rewrite human understanding once again. These monsters do not disappear because they seem absurd. They do not change because we struggle to believe them. They've been there all along. And the next time you look up at the night sky, you might realize the truly unreasonable thing in this universe is not those cosmic monsters, but the fact that we humans can understand even a tiny bit of them. May the vast universe stay with you. I'll see you in the next episode.